Most people believe the engine is the heart of a car, but what happens when that heart is replaced completely? Some cars become classics because they're fast. Others become classics because they remind people of a different time. The 1962 Mercury Comet station wagon belongs to the second group. Built more than 60 years ago, it represents an era when family wagons were designed with simplicity, practicality, and unmistakable American styling. But while its appearance has stood the test of time, the technology beneath the body has not. Classic cars were built around engines, transmissions, and fuel systems that belonged to another generation. Keeping them on the road often means accepting outdated performance, constant maintenance, and limited reliability. Danny believes there's another way. Instead of restoring this Mercury Comet exactly as it left the factory, he's giving it a completely new drivetrain. The goal isn't to erase its history, it's to preserve everything people love about the car while replacing the technology hidden underneath with something designed for today's roads. Every year, thousands of electric vehicles are written off after accidents, even though many of their most valuable components are still fully functional. Beneath the damaged bodywork, the electric motor, battery pack, inverter, charger, and countless electronic systems may have years of life left in them. For builders, that turns a totaled car into something far more valuable than scrap. That's exactly the approach Danny takes in this project. Instead of buying brand new EV components, he purchases a wrecked 2014 Nissan Leaf with one goal in mind: salvaging its complete electric drivetrain for a future conversion. The body may be beyond repair, but if the electrical system survived the collision, it could provide almost everything needed to give another vehicle an entirely new life. Every custom-built suspension has to solve a unique set of engineering challenges. Unlike factory components, there's no instruction manual or off-the-shelf solution. Every part has to be designed around the vehicle it's built for, especially when an electric drivetrain changes the available space beneath the car. This custom de Dion axle reflects exactly that approach. Its stepped design creates additional clearance around the electric motor while maintaining the strength needed to support the rear suspension. At the same time, the motor mounting system has been designed to maximize the available space without compromising the overall layout.
Wow, yeah.
I am lucky that I did not get hurt.
A weld isn't usually the weakest part of a metal component. A bad design is. That's one of the biggest challenges when modifying CV axle shafts. They have to transmit the full torque of the motor every time the car accelerates. So even a small weakness in the joint can eventually lead to failure. Instead of ordering expensive custom-made shafts, Danny modifies the originals. Here's the interesting part. The weld itself isn't the biggest challenge. The real challenge is designing a joint that's strong enough before the welding even begins. That's why Danny doesn't simply weld the two shafts end to end. Instead, he uses a modified lap joint that creates a much larger contact area. Rather than forcing all the load through a single weld, the design spreads those forces across the entire joint. After all the cutting, machining, and welding, Danny's custom axle shafts are now 3.5 inches shorter than the original Nissan Leaf shafts. More importantly, the redesigned joint provides a much stronger connection than the simple splice methods commonly used in DIY conversions. Getting one system to work is challenging. Getting parts from two completely different cars to work together is something else entirely. Although the electric drivetrain comes from a Nissan Leaf, the mechanical parking brake is built around Honda components, bringing together parts from two completely different vehicles. Every electric car has a hidden highway running through it. You never see it, but every time you press the accelerator, enormous amounts of electrical energy travel from the battery to the motor in just a fraction of a second. Without that pathway, the car simply wouldn't move. That's exactly what Danny is building here, the electrical pathway that will carry every bit of power from the battery to the motor. The power delivery module houses the onboard charger, the DC to DC converter, and several other electrical systems that keep the entire vehicle running. In many ways, it acts as the electrical hub of the conversion, managing how energy flows through the car. Sometimes, one of the most expensive parts of an electric car also happens to be one of the most exposed. The inverter and power delivery module sit directly in the path of everything the road can throw at them. That's why Danny installs a skid plate made from steel beneath the assembly, protecting these critical components from impacts that could easily cause costly damage. At first glance, this is still the same fuel door the Mercury Comet left the factory with more than 60 years ago. But what sits behind it is about to tell a completely different story. For decades, this opening was designed for one purpose: filling the tank with gasoline. Now, Danny is transforming it into the car's charging port, replacing liquid fuel with electrical energy. By keeping the charging port hidden behind the original fuel door, the car preserves its classic appearance while gaining a completely modern function. Unless someone opens that small door, they'd never guess that this old classic station wagon is no longer powered by gasoline.
All right, let's get under here and I'll show you everything that I've installed so far. Yeah, we have the charge ports installed, the inverter and the charger here, motor here, which we did in the last video, the axle tube finally all installed with the axle shafts as well. The shocks are now installed, new leaf springs installed. The brakes are installed. To get the brakes to fit, I had to use these aluminum blocks here to create some space.
Until now, the battery, inverter, motor, and high voltage wiring have all been installed separately, each serving its own purpose. The real test begins here. For the first time, electricity will flow through every major component exactly as the system was designed.
Give her a reach around over here to turn on the ignition. Oh my God, yes! Ah, yes! Let's see if the brake pedal works, and then I can shift it in the drive. Oh my God, here we go. Here we go, here we go, here we go. Ah, okay, watch the tires. Whew. Oh my God. Is that going forward or backward? It's supposed to be going in reverse. The current sensors are these doohickeys right here. And the simplest way to understand this, the phase wire furthest from the female connector for the wiring harness is the one you need to swap. And you can swap it with either of the two other ones. Yeah, baby, that's forward. And now reverse. Yes! Yes!
An electric car battery isn't built to be taken apart. In fact, it's one of the few components most manufacturers never expect anyone to open. But to make the Nissan Leaf battery fit inside a 1962 Mercury Comet, Danny has no choice. The entire pack has to be dismantled, reorganized, and rebuilt into a completely different shape. Putting a battery pack together is a bit like solving a puzzle. Every module has its own position and direction. Get just one of them wrong, and nothing will work the way it should. As Danny checks each module before assembly, he finds that several were damaged earlier in the build and now need to be replaced. With every battery module that's added, the pack comes a little closer to life. At the same time, it becomes more dangerous to work on, as the voltage continues to rise. But high voltage isn't the only concern. Every battery module has a positive and a negative side, and each one has to be installed in exactly the right direction.
Let's check it now. And once again, we have 95.5 volts.
Every reusable part is carefully set aside for the new battery pack, while replacement modules have to match the originals as closely as possible. Even small differences in voltage or battery condition can affect how the entire pack performs once it's back together. Safety remains a constant priority throughout the process. When working with high voltage batteries, good preparation is often just as important as the work itself.
Ah! Whoa! That's why you need to be careful.
Before the battery can power anything, there's one final question that has to be answered. Has every module been installed correctly? Danny traces every positive and negative connection through the entire battery pack, checking the polarity one last time before applying power. A single module installed the wrong way could damage the entire pack in an instant.
Just about finished up installing the inline 24. The smaller wires, all of the smaller wires and the low voltage wiring is done. Here's the BMS mounted. I put the lead acid battery back in as well. The very last thing to do is just connect the cables here to the battery pack modules. Alrighty. Okay, got it. There we go, 381 volts. Time to connect the lead acid battery. The car's ready to turn on now, just like that.
The numbers behind this project are just as impressive as the engineering. A professionally built conversion can easily cost around $40,000. From the very beginning, Danny had one clear goal: to complete the entire conversion for less than $6,000. Against the odds, he actually did it. The electric conversion may be complete, but the story is far from over. The next chapter will transform this classic Mercury into something every Ghostbusters fan will recognize. More importantly, it will fulfill a promise Danny made to his 3-year-old son, who can't wait to see his own Ghostbusters car come to life. Every great project begins with an idea, and this journey is just getting started. Subscribe to Mercury to follow more complete build stories and share your ideas in the comments. We're always excited to take on the next challenge.